Okay, so let's take a look at how to sketch linear rational functions. Little bit of a step-by-step guide. Okay, so if you want to sketch a rational function, first of all, we need to think about, well, where are the asymptotes? And once we figured out where the asymptotes are, we need to think, well, where does it cross the x-axis, where does it cross the y-axis? All right, let's try example 1. And example 1 says sketch y equals 4 minus 2x divided by x plus 1. So let's start with the vertical asymptote. Remember, if we can't divide by 0, so look at the denominator and think, well, if x plus 1 equals 0, that would be when x equals minus 1. Horizontal, that's as x tends towards infinity. And then, so as x gets larger, we can think about this as a fraction that looks like this. Essentially divide everything by x on the top and on the bottom. Remember, you're allowed to do that because it stays the same as long as you do the same thing on the top, same thing on the bottom. And then we'll say, well, as x gets bigger, 4 divided by, if x is really large, 4 divided by large, it would tend towards 0. And 1 over x would tend to 0, so y would equal, if that tends to 0 and that tends to 0, we've got minus 2 over 1. Be careful with your notation here. See the way I'm using these arrows to say that these individual things tend towards, so as x tends to infinity, this term tends to 0. When you're actually stating what your asymptote is, your asymptote should be an equation. So don't say y tends towards, the equation for your asymptote is y equals minus 2. The equation for your asymptote is x equals 1. Just make sure you write it as an equation, not as a tending towards. That's just for you working out. Okay, so once we've done that, we can think about where's it across the x-axis, where's it across the y-axis. For the y-axis, if x equals 0, it's the easy one, so y would equal 4 minus 0 divided by 0 plus 1, so y would equal 4. So we've got the coordinate 0, 4. And the last one you've just got to be careful with when it crosses the x-axis. I've seen people go wrong with this one in the past. So when y equals 0, we're solving 0 equals 4 minus 2x divided by x plus 1. Just pause for a second and have a think about how you're going to solve that equation, because that's important that you can do this. It's a little stumbling block for people sometimes. Okay, so what happens when you've got a fraction equal to 0? Like, we're trying to solve this. And obviously, the best way to approach this is like, you've got multiple x terms. So I'm thinking, well, how can I simplify this? How can I rearrange it? And the first thing you want to do is you want to get rid of the fraction, don't you? Now, how do you get rid of the fraction? Well, you multiply both sides by x plus 1. But think about what happens if you multiply by x plus 1 on the left-hand side. You've got 0 multiplied by x plus 1. Guess what? You've still got 0. Okay? And obviously, if you multiply the right, you're left with just 4 minus 2x. Okay, so really important that you remember, whenever you get a fraction equal to 0, it's just the same as saying the numerator, the top bit, is equal to 0, because if you multiply up, you multiply both sides, you're just left with the numerator equal to 0, so that's what we have to solve for this one. So 2x would equal 4, x would equal 2, so our coordinate would be 2, 0. Okay, so now we've got all the information that we need to be able to make this sketch. Let's see if I've got enough space. Okay, so when you're going to draw this, my advice would be think about where your asymptotes are. So I've got an asymptote at y equals minus 2. So you don't want to draw an axis like this because your asymptote is at minus 2, and essentially most of the good and sort of important stuff goes on down here. So you want to think carefully, especially if, imagine if one of your asymptotes was like y equals 7. If you were drawing it like this and y equals 7, you'd be drawing an asymptote all the way up there. So just pause for a second and think about whereabouts this graph is going to be centered. Okay, x equals minus 1. So x equals minus 1. Apologies for the terrible line. Let's use a ruler, obviously. X equals minus 1. Y equals minus 2. Make sure you label your asymptotes. Okay, and then we know it goes through at 2, 0. Okay, so 2, 0. would be there. And we know it goes to 0, 4. So I haven't listened to my own advice, have I? I'm just going to... Good thing about the whiteboard. 0, 4. Again, it doesn't need to be like exactly accurate, but if you do it to scale, it helps a lot with the shape of the graph. Okay, so 0, 4 would be there. Now you might think, well, how do I know what the graph looks like? Because both of the intercepts are in the top right quadrant. But remember that the graph is going to have this shape. It's either going to be that shape or it's going to be that shape. So because we've got 2 points up here, we know that the graph's going to come down. And be really careful when you're drawing this, just make sure it gets close to that but never touches. Okay, now I should have given myself more space for this. Once you've got this section up here, it should be roughly symmetrical. So the other section would be around about the same distance away from this point where the two. Don't just draw that like that up there. Like you're looking for a roughly symmetrical sort of diagram, which has like got some rotational symmetry about the center. So we should also draw it down here like this. Okay, and that would give you the marks in the exam. Like label your asymptotes, label your intercepts, and let's try one more. Okay, it's a slightly more complicated one now because we've got two terms, and the denominator's got a little bit more going on. But don't panic, same process. So if you wanted to sketch this, vertical asymptote, denominator, so 3 minus 2x equals 0. And then if we rearrange this, just be careful as you rearrange. X would equal 3 over 2. Okay. The reason why I chose this one is because the horizontal one can cause issues. So for your horizontal, you're thinking about it as x tends to infinity. So let's just focus on, let's do the whole thing. Okay, so y would equal, you don't forget this plus 2, essentially this is where people go wrong. Okay, so if we divide throughout by x, we've got 1 over x, 3 over x, minus 2. Now as x tends to infinity, 1 over x would tend to 0, and 3 over x would tend to 0. So y would equal 2 plus 0 divided by minus 2. That would, obviously when you get 0 divided by something, it gives you 0, so the asymptote would be y would equal 2. Okay, so we've got our two asymptotes. X equals 3 over 2, y equals 2. Let's find where it crosses the axis. Okay, so for our y-axis, we know that x equals 0. So y would equal 2 plus 1 over 3. You could write it as 2 1/3, but we don't normally use mixed numbers, okay? Probably best if we write it as 7 over 3, okay? And then for the x-axis, y would equal 0. So be careful how we solve this. We've got 0 equals 2 plus 1 over 3 minus 2x. So we need to rearrange this equation to figure out what x equals. Obviously we've got this fraction that we want to get rid of, but just a little mistake that sometimes people make, if you do multiply by 3 minus 2x straight away, obviously 0 times by this would still be left with 0, but don't try and like get rid of the GCSE mentality of like, oh, let's just throw it over on the other side of the equation. You've got to look at the equation and realise that this term here is important. Like if you multiply everything by 3 minus 2x, you've got to multiply this one as well. Okay, probably slightly better way of doing it is just to do a little bit of rearranging first. If you subtract the 2, then multiply by 3 minus 2x. We've got minus 2. Brackets important because minus 2 is being multiplied by all of this. 3 minus 2x. Okay, so that gives minus 6 plus 4x equals 1. So 4x would equal 7. X would equal 7 over 4. Okay, so I'm going to give myself enough space for this one. Okay, so we've got y equals 2. For our horizontal, x equals 3 over 2, which is like 1.5, so slightly less. For your vertical one. And then it goes with 0, 7 over 3. Okay, now 0, 7 over 3, that's like a little bit bigger than 2, isn't it? That's 2 1/3. Okay, so there's 2, 7 over 3. Think about that, that's 6/3. We've got 7/3. So 7 over 3 would be just above. And then we've got 1.5. We've got 7 over 4, which is like 1.75. Okay, so it'll be, again, write 3 over 2 there. 7 over 4 would be there. Okay, so I'm glad this has happened actually. We've actually got one that instead of being orientated this way, is going to be orientated the other way. Okay, so all we've got to do now, like my advice would be as you draw this, just concentrate on getting closer to this line, but don't touch it. That's all I think about. Like, I want to get closer to this line. Nice smooth curve. And make sure it's like, it clearly doesn't touch. Like, it's hard with the whiteboard pens because they're not exactly very fine, but just make sure it doesn't actually touch that line. Okay, if we go up this way, just going to approach this. Please don't. I've seen people do this. Like, I don't know why, but sometimes people get there and then they curve back down again. Like, you can't do that. You need to make sure that it gets closer to that line but never touches it. Okay. And we've got 7 over 4. And then for this one, it's not easy to do on the whiteboard. We're gonna go up, approach the asymptotes, but not touch it, and down through this way. Okay. There you go.